Now we're continuing on with part B of lesson on section 3.1 on uh, our topic that was measures of center. And so we worked on the calculator to find the mean, the median, the mode, and mid-range. Okay, so now we're going to do more examples, and we evaluated outliers. Sorry about that. And we made some decisions on the fact that the extreme ones were the ones we needed. And we said 39 was not as extreme as the 1500 and 2000. So we're going to do more examples. And each one getting us more involved with the analysis aspect of data. The first one, we found outliers, and that's always a criteria. But on this next one, we're finding out the mean and the median for the data and then comparing it. So let me read it for you and you follow along. Listed below are pulse rates, beats per minute, from samples of adult males and females. Find the mean and median of each of the two samples, then compare the two sets of results. Does there appear to be a difference? So we're analyzing the differences between male and female pulse rates with a small sample set. So we're going to get our calculator, clear our home screen. We're going to do the stat edit to enter the data. We're going to up arrow, clear, enter. And we're going to carefully enter the data for males first. 65. And it's not bad. And you can always put me on pause to enter the data. And I show that we have 14. Let me see if we do. Oh, we have 50. So again, working on here, I have omitted something. 65, 95, 53, 80, 79, 69, 59, 86, 50. Oops, sorry about that. 86, 58, 78, 52. Golly, doggone it. It's difficult on a simulator. 52, 72, and I left off of 52. All right. So now I have the data in, And the order was not important. I just needed to know that I count and make sure. So I'm going to do on the second one, I'm going to calculate 5-number summary. So I'm going to do that. Stat calc number 1, enter, enter, enter. And all I need are 2 items. I need the mean, and we're going to do 1 decimal, 1 decimal. I didn't type that in. So let me do that. I have 72.46. So it's 72.5. And now we're going to do the median, and the median is 72. Immediately we see those two are similar, that the mean and mean are very closely related. So now we're going to do the females. We're going to enter data for females. There we go. And I'm going to do something different this time. Let me clear it. Stat, edit, and I'm going to arrow over to line 2. If line 2 has data, remember to up arrow, clear, and enter. And we're going to enter that 72, 85, 88. Oh, the 9 on that one was 90. All right, now I match. Oops, so I'm good. So now I want to calculate. All right, so I'm going to do a stat key. I'm going to do a calc and enter. But before I do anything, I'm not doing line 1, I'm doing line 2. So I'm going to enter second, number 2, and line 2 appears. Then I'm going to enter, enter, enter. And I read the X bar is 84. And the median is 88. Okay. So we noticed that the males are closely related and the females aren't too bad either. In other words, the mean and the median are pretty close as well, but not as good as the males. But they talked about difference. Difference. So the males, X bar and medians are in the 70s. Actually, 72. So I'm going to put 72. Whereas the females run a little higher, right? the X bar and median are in the 84s. Okay, so we can see that we're having higher pulse rates. Okay, so now we're looking for the one that makes sense. The mean is lower for males, true, but the median is lower for females, and that is false. So it's not number one. The mean and median appear to be roughly the same for both genders. This is false. They are not the same. The men medians are 72.5 and the females are 84. It's not that one. So let's look at the next one. The mean and the median for males are both lower than the mean and median for females. That is true. That's my first guess that it is true, but we have to read all of them in case I've made a mistake. Okay. The mean and the median for females are both lower. Oop, that's false. The median is lower for males, but the mean is lower for females. No, that's false. Okay, so we made a correct choice. The best choice in the differences, in the study of the differences, is the mean and the median for males are both lower than the mean and the median for females. Does there appear to be a difference? All right, so now we're coming to our conclusion, right? Remember, we talk about conclusion, and I always say inference, what the data tells us. All right, so let's see what we have. The pulse rates of males appear to be higher than the pulse rates of females. Oh, that's false. Since the sample size is small, that's true, because it's only 14, no meaningful information can be analyzed, and that is false. Because the mean and medians are relatively the same for each gender. All right, so that one is false. You can't make a statement like that, knowing that the information we got is pretty good. It's pretty representative. The pulse rates for the females appear to be higher than the pulse rate of males, and that is true. The men are in the 70s and the women are in their 80s. There does not appear to be any difference, and this is false. So C is our answer for that. So here we go. Everybody ready? We have the consideration what we're talking about here. Class frequencies. I'm finding the information, finding mean, median, mode, modius, etc. Okay, from the 5-number summary. So I've written this part right here. and it is calculating the mean with data that is in classes. So we're talking about a histogram or frequency table. And the first thing is calculate the average of each class. All right. And then multiply average times frequency, because that's a repetition of that particular value. Find their sums and divide the whole frequency. So here we go. Find the mean of the data summarized in the given frequency distribution. Compare the computed mean to the actual mean of 51 and 4/10. All right. Here we go. So we want the mean. So we have the 40 plus the 44 divided by 2. And I get 42. And I have the 45 plus the 49 divided by 2. And that looks like 94, doesn't it? I get 47. Now we see the change here as a plus 5 because that's the size of the of each class is 5. But we want to do the math so that you can see what's going on. 50 plus the 54 divided by 2. 104 divided by 2. 52. Well, if I add 5, I get that one. So now I'm at the 55 plus the 59 divided by 2. Looks like 114, doesn't it? Divided by 2. That's 5, and 14 makes 7. Again, that plus 5. Again, all of mathematics is pretty much a pattern if you can see it. Some of them are more complicated patterns, but they're not difficult if you calmly look at what you have. 124 divided by 2 is 62. So these are the values we have of the frequency class. So what we have now is the 42 twice. And now we have the 47 6 times. And then we have the 52 8 times. Now we have the 57 5 times. And 62 once. Now what we've done is find the center value. So we want the mean for this. All right, so let's do the mean. So we're going to have parenthesis 42 times 2 plus 47 times 6 plus 52 times 8 plus 57 times 5 plus the 62, and we're going to divide that number by 1, 2, 3, 4, 5. Oh no, I have to add them. Sorry about that. Sorry. We're going to do by, oh, if I can do my pen. 2 plus 6 plus 8 plus 5 plus 1. All right, because that's a total number of data. All right, so we're going to do that. When I do the math on this guy, I'm going to do my calculator. Oh, sorry. Hit the wrong label here. Okay, now that I have the calculator, sorry for the pause, I clear up my home screen And I notice I put parentheses. So I'm going to enter parentheses. And I'm going to do 42 times 2 plus 47 times, make sure I have the times, 6 plus the 52 times 8 plus the 57 times 5, making sure I've got the times, plus 62, close parenthesis, divided by, open parenthesis, 2 plus 6 plus 8 plus 5 plus 1, close parenthesis, and enter. And I get it as 57 and 400ths. So I'm going to look again to make sure I have everything correct. 42. Oh no, I put a 5 there and it should have been a 2. Sorry about that. Second entry, and that tells you if you do second entry, you can just go back. It isn't. Let me look. It's 42. Let's see what I. Oh, I see what I did. I'll just do it again. 42 times 2 plus I don't know if I 47 times 6 plus 52 times 8 plus 57 times 5, making sure 57 times 5 plus a 62 divided by, and then this one I'm just going to add 10, 21, 22. I'm going to take a shortcut and do 22. Bam, there you go. So I'm going to have, we always talk about garbage in, garbage out. So we have this long decimal of a repeating decimal to be exact, but we want at least one decimal place. So it is 51 and 3/10 degrees. Okay, so now we're going to analyze what we just got. Remember what it said. It said from the raw data, because we only have classes, that the mean was 51 and 4/10. And from our average of classes, our mean is 51 and 3/10. So they are what? Oh yeah, close. So let's see which one suits us as an appropriate answer. The computed mean is close to the actual mean because the difference between the means is more than 5%. No, that is false. It is not more than 5%. It is a very small. And the use of 5% is those extreme areas, the closeness. So if we did the mean difference, we had a 0.1 divided by the 51.4, which is the actual. And that would give us something really, really small. It's really less than 5%. All right. The computed mean is close to the actual mean because the difference between the means is less than 5% of the actual mean. Bam, that's what we have. The computed mean is not close. Well, that's wrong. This is false. And the computed mean is not close. Again, false. They are close. All right. So now we're going to do another example. And this one I inserted because it affects how you perceive uh, your grade analysis. And this one is on a 4-point. Now, remember in your college transcripts, you want to be in the 3.3 or higher. As we get more sophisticated, that would be what they call an average, and that would be in the B range, that your overall average is in the B range. Well, classes are sometimes they are 3 hours or 4 hours if you have a lab, or 2 hours if you have a personal study, or 1 hour. So these impact your average GPA, grade point average. So let's look at this one and we can make sense of what we're doing here. All right, here we go. A little bit of math, nothing difficult. A student earned grades of an a B, a B, a C, and a D. F is failure. You get no points for and lose quite a bit because of the number of hours that you're taking that you got the F. Those courses had these corresponding number of credit hours. Okay, so they took some kind of a science or a math course, and it was 4 4 4 hour classes. Then they took a 3, probably an English, right? And a 2, which is a get acquainted to college. And so now this is your hours for semester. So let's add how much. This is a very hard schedule. So this is 12, 15, 17 hours for this semester. It's quite a bit. He must have had permission. Now we need to know what we multiply. We're going to multiply the hours times the grade distribution. Now let's read on that. So in this case, it said the grading system assigns a quality points to letter grades as follows. A is a 4. Okay, so he got 1 4. B is 3. Well, he got 2 that made B's. C is a 2. And a D is 1, and an F is 0. So we're going to multiply the values times each of the hours for that course. So this would give me 16, 12, 12, 6, and 2. All right, so now we need the total. So our total and we're going to divide by the number of hours taken in the semester. All right, here we go. So I'm going to take my calculator just not to make a mistake, even though I have been on the tables, and I apologize for that. 16 plus 12 plus 12 plus 6 plus 2. Enter. I get 48. Now I'm going to do the total number of points, 48, and divide by the semester, 17. I'm going to need my calculator. And I get an outrageous number, 2.8235 and onward. And we do GPAs on 2 decimal places, so it's 2 and 82 hundredths. All right, so let's see what we can say about this. The student's GPA is 2 and 82 hundredths, round to 2 decimal places. The student, what does it say? Did make the dean's list because their GPA is greater than or less than. Now remember what it said up here. The dean's list requires 3 or greater. So the student did not make the dean's list because the GPA is less than the 3.0. All right. That's crucial in your life. Yeah. So I have one more problem. I know I've been doing a lot of talking, and I'm sorry about that, but I need you to have a handle on how you're going to do this homework. We have one more example. 5 pulse rates are randomly selected from a set of measurements. So we have our cardinality of our sample as 5, and with a mean of 64 and 6/10 beats per minute. And then it says 4 of the pulse rates are 53, 94, 54, and 59, and we're missing one, and we have an X that we don't know. Find the missing value. All right. So we know that the X bar is the sum of the data divided by the number of data. So let's see what we have. So we're going to have 64 and 6/10 is equal to the 53 plus the 94 plus the 54 plus the 59 plus X divided by 5. All right, so we know to undo division, because 5 is a division, we're going to multiply both sides by 5. So I'm going to have the 5 times the 64.6, and I'm going to get the value of, I think that's 323. And now I have the 53 plus the 94 plus the 54 plus the 59 plus X. So I'm going to have to simplify that right there. So I'm going to add on my calculator the 53 plus the 94 plus the 54 plus the 59 and get to 260. Now, to get rid of this number, I have to subtract it from both sides. So I'm going to subtract 260 from both sides. And I end up with 63, and this zeros, and I end up equals x. The missing value is 63. All right. Now, the second part is, suppose that you need to create a list of n values that have a specific known mean. Some of the n values can be freely selected. How many of the n values can be freely assigned before the remaining values are determined? The result is referred to as the number of degrees of freedom. So what we have is whatever the number is minus 1. Of the n values, something can be freely selected because the remaining values can be expressed in terms of assigned values to the known mean. So we're saying that of the n values, can what do I need? N minus 1. It's what I'm looking at. For degrees of freedom can be freely selected. Of the n values, minus 1 can be freely selected because the remaining values must be equal to the known mean. Not equal. This is not equal. So this one false. Even if we use n minus 1. Of the n values, n minus 1 can be freely selected because the remaining values can be expressed in terms of the, no, that's too much information there. This one is false. So this one is it. N minus 1 can be freely selected because it's one element. N minus 1 is what we need. And I'm sorry, we're going to say 1. Just the 1. Of the n values, 1 can be freely selected because the remaining values can be expressed in terms of assigned values and the known mean. So n minus 1 is called a degree of freedom. And we're going to talk about that later on, where you can have this floating value that we don't know, and it can be in the range of half below and half above, and it'll still come out correct. All right, now I need you to do your homework. So thank you so much for working these with me and being patient.